right now. I always forget. Somebody needs to remind me. Okay, so here's our agenda. It's in the chat, and you can see everything we're going to talk about today and all the links. So you don't need to go, try to copy the link and put in your notes. Everything should be here. And if it's not, just let us know and we'll add it to this. So the purpose for today is just to give you an overview of computer science, and hopefully you can walk away with something that you can use tomorrow, or at least something new you learned. So we already covered the 5 core concepts. We gave an overview last month in August. So this month we're going to focus on computing systems, which is one of the 5 core concepts. And it's really small, so I'm going to go close. So the 5 core concepts consists of devices, hardware and software, and troubleshooting. Okay? It's more than just coding. So here's an example. This is a real life example. So one day our printer in our office did not work for everyone. We said, hey, can you print? No. Can you print? No. So everyone in the office was not able to print. So our administrator, Charles, actually went down on the floor and looked at the wires and tried to figure out why our printer was not working. And so we found out that when they redid the phones in our office the day prior, they disconnected the printer from the telephone, and the telephone was the connection to the internet. So basically our computer was not on the internet, it was not on our Wi-Fi. So he plugged it back into the Wi-Fi, and boom, our printer talked to all of our computers in the office, and it was working again. So this is a good example of troubleshooting. Okay, next slide. So I'm going to turn it over to Faith now, and she'll go into a little more detail.
Okay, thanks, Janine. Yeah, so as Janine mentioned, we did an overview, and today is a little deeper look into computing systems. And the sub-concepts, devices, hardware, software, and troubleshooting are all listed here, and these are the standards that we're going to cover. And we included links to these standards, as well as a link to the K-12 progression chart for computer science, and a link to standards for computer science teachers. So if you were to click on that progression chart, this is what it would look like. On the far left, the darkest colors are the core concept. And to the right, the associated lighter shades are the sub-concepts. And then you can go down further to the right and look at the grade level progressions. So how do computers work? Well, we're going to show you a little snippet of a video and listen to see if you can identify what makes up a computing system.
Under the hood, all computers do the same 4 basic things. They input information, store and process the information, and then output information. Each of these things is done by a different part of the computer. There are input devices that take input from the outside world and convert it into binary information. There is memory to store this information. There's a central processing unit, or CPU, where all the calculations are done. And finally, there are output devices that take information and convert it into physical output.
Okay, so keeping that in mind, look back at our slides. So here are some pictures of, traditional looking devices and almost maybe older looking devices. And if you could put in the chat, which one of these or any one of these that might be an output device?
And the numbers are in the lower left corner. If somebody in the morning session said, what's number 7? I can't tell what number 7 is. So there's a little key to the left. So number 7 is a modem, for example.
Yeah, so 6 input, printer, slash, 6 scanner, awesome. Yay, great ideas. Okay, so might there be any input and output devices amongst these items? So I wasn't sure myself. Yeah, right. So I kind of had to look it up, and thanks, Danny. And one of them is the modem too. Scanner 7. Yeah, right. Because it takes in information and then it also sends it out. Okay, so we got a pretty good idea of that whole concept of input, output, and memory and processing. So here is another video by Linda Lucas, and she's an author illustrator. And this might be a kind of fun activity for your students. So I'm going to go ahead and play this video as well.
There are many different ways to put information into a computer, like the keyboard or a mouse. These are called input parts. Other parts allow the computer to send information out, like the monitor or a printer. They are known as output parts. Some parts can be both input and output. Cut out the input and output devices. Can you figure out which is which? What about making your own new input or output device for the computer, like a mouse, a video camera, or VR headset? Input and output, or I/O devices, are the pieces of hardware used to communicate with a computer. You can think about computers as devices that process information through input devices and show it through output devices. When taking a photo, the camera recognizes your face. That's the input data. Then there is a piece of code that processes the photo and maybe adds a filter. And finally, your photo appears on the screen. That is the output.
Okay, so I'll go back to our slides. That sorting game is in a book by Linda Lucas, and she has a series called Hello Ruby. So we're going to take a look at one of the titles in her series, Journey Inside the Computer. So in this story, this little girl, Ruby, is bored, and so she goes to her father's computer and turns it on, and she realizes that there's no cursor. So she talks with her friend, the mouse, and they decide that they're going to go inside the computer and check it out. So they tumble down into the computer, and she can see all the bits turning off and on. And she finds the central processing unit, bossing everybody around. She finds the RAM and ROM storage. And until she goes through a series of steps to try and troubleshoot and finally find the cursor that had been missing. In the back of the story are about 25 different exercises that you can use with your students. So this particular one is making a paper computer with all of the parts that go inside that we learned about. And then we have the Piper kits, which are a little bit more realistic, and it provides a blueprint, and students or adults, this our administrator and colleague, put together following the blueprint, actually put the pieces together and make a working computer. Yeah, I think Anna did one with us as well. That was fun. Just have to think about the management of the little pieces, but it's an awesome experience. And then we visited Mokapu Elementary, and they have a Girls Who Code Club, and their facilitator, Adrian Ulu Vincent, saves computers and laptops from campus, and she allows her Girls Who Code Club students to open up the bag, take out all the pieces, and get a real live look at what it's all about. So we've kind of looked at computers and devices in a little bit more traditional sense, but what are computers starting to look like today and into the future? And do you think they'll ever take over the role of humans? Well, let's take a look at what Linda says about that.
Hi, my name is Linda, and today we'll talk about computers. Computers are everywhere around us. You probably have over 100 computers in your house, because computers are not only the desktops and the laptops, and they are not defined by the screens anymore. You can find a computer in your fridge, in your toothbrush, and in your teddy bear. This generation of kids will be the last one to remember the computer as the glowing box. So I have here a few pictures. I have a picture of a car, a book, a grocery store, a camera, and a mobile phone. Guess which one of these is a computer? Well, all of these are computers because, for example, a car has a navigation system, which is a computer. And a grocery store has all sorts of computers inside of it. They have burglar alarms and cashier machines, and even the ice cream box that keeps the ice cream cold is a computer. If you ask your parent how a computer actually works, you'll probably get a blank stare. Inside the computer, there are a lot of small components. Each one of them has a special role. Computers are built with hardware and software. The electrical or mechanical parts of a computer are called hardware. The instructions and the programs inside the computer are the software. Hardware and software work together to run a computer. So first we have the CPU. It's very good at bossing everyone else around, but it has a hard time remembering things. The CPU is extremely fast at calculating things, but it has a very hard time remembering things, so it needs the help of the others to remember. Next, we have the GPU, the graphics processing unit. It's very similar to the processor, but it focuses on things that are shown on the screen. Next up, we have the mass storage. If you have something that you want to remember for a long time, like your family vacation photos or your game levels, you need mass storage. The bad thing about mass storage is that it's extremely slow as a memory type. And this here is the RAM, the random access memory. It works furiously between the mass storage and the CPU, delivering all of the immediate information and working as a quick memory between the two of them. But when you close the computer, the RAM forgets everything. And finally, we have the ROM. The ROM includes all of the information that you don't accidentally want to delete from your computer, like the instructions on how to open up the computer. Computers might look smart, but all they do is calculate. Computers run a huge amount of simple calculations one after another, but they would have a hard time understanding that for humans, heart means love, and they wouldn't know what love feels like. Computers don't come up with solutions on their own. They need instructions. People, on the other hand, can think creatively and independently. That's why we make such a great team.
Yay. So we know now that no matter how much the computers progress, we do still need humans. Oh, oops, let me change the slide. So this is an activity. You might have a discussion with your students about what computers looked like 10 years ago and what they're looking like now and maybe what they could be 10 years from now. So here's on the left is human neutral little neighborhood. And if you look at this picture, what might be running on computer systems? maybe type in the chat things you notice in this neighborhood that run on computing systems. Yes, the washing machine, definitely. Oh, ketchup. Yes. Traffic lights. Awesome. Very observant group thing. Uh-huh. That little shop window has a whole bunch of stuff in it. And it, as I was looking at it too, I was wondering, you know, with now with COVID and the technology, I wonder if one day the door is going to sense if we have a temperature that is too high and maybe won't open for us, and things like that as we progress into the future. And as you look to the right, that our cell phones that we all have, that's another tiny little powerful computer that you can have discussions about with your students. Thanks for participating in that. So one of the other standards we thought we'd mention is the troubleshooting. And here are some articles with really basic, easy to follow ideas in terms of troubleshooting. So I'll just open up one of them. And it has, you know, things like write down the steps that you've taken so that you don't repeat them again. Or if somebody asks you, what have you already tried? You can be sure to answer accurately, and taking notes of the error message. And I think Janine said maybe, or somebody said, taking a picture of the error message, because sometimes it's a lengthy message. Checking the cables, that's what our administrator did when our printer didn't work. And actually, here's a scenario about a printer that doesn't work and all the steps you might take to check it out and see what the problem is. So lots of handy, simple solutions to really common problems that we all encounter as we're troubleshooting. So again, just to go full circle, these are the computer science standards that we covered today and some of the links. And if you want to access that Hello Ruby series of titles or any other book, we have a statewide ebook collection, and you can access it by going to soraapp.com. And here's another book that's in that collection, What's Inside My Computer, that not so much drawings, but actual photos of the parts inside the computer. And this is a video we showed the last time, and if you haven't seen it, I kind of encourage you to take a look, because it looks specifically at Hawaii DOE, where we were in the last 2 or 3 years, where we are now, and what the future next 2 or 3 years looks like, and how there is legislation in place to ensure that learning opportunities are available for about computer science for all of our students from K to 12. And I'll turn it over to Janine.
Right. So coming up in October, from October 18th through the 22nd, is Digital Citizenship Week. And that falls under the impacts of computing for computer science. So if you click on the link up above, Common Sense Education has a wealth of resources. However, they're all free and they have tons of resources, but it is so easy to get overwhelmed. So what we've done, or what we're still doing, is we'll wade through all of those resources and find the best ones to help you get started. So we will have a kickoff. We're going to record it next week, and we will put the link to the recording here and in the flyer. And if you participated here today, I'll probably send you an email to thank you for coming today, and also future links to our other events. So basically, we'll do a 15-minute asynchronous session and you can watch it whenever you want, and it'll be like just a get started compendium of resources from Common Sense Education and what you can do during Digital Citizenship Week with your school or your classroom. Okay, next slide. So here are some additional resources for elementary and secondary that we compiled for you. So if you have time or you're interested in learning more, maybe from a secondary perspective, here are some links. So every session we do focus on, a specific grade band. For example, more elementary, maybe during this session. But if you're wanting to teach middle or high school, we try to provide resources for the middle and secondary or middle and high school teachers also. Next. So we are at the end of our session, and we're going to give away a door prize. We gave one away this morning, and we have a couple more, or at least one more. If there's a tie, we have an extra just in case. So at the last session, we gave a prize to whomever's name was closest to the word Byron, because Ada Lovelace, the first computer programmer, her father was Lord Byron. So we said whoever's name was closest to the name Byron at the last meeting would get a prize. Okay, so this time we're going to test your thinking skills and see if you can sort things and put them in order and then come up with whose name is the farthest away from the name Linda. Okay, so whose name is the farthest away alphabetically from the name Linda? Okay, and put your name in the chat if you think it's you. Or if you know whose name, look on the participant list. If you know who it is, put their name in the chat. Okay, so I'll also type it in the chat, because some of you, if you're like me, you give me verbal directions, I'll go, huh? What did you just say? So I will type it in the chat. I'm trying to multitask, so excuse me.
So Carrie is suggesting it might be Anna. Anna is suggesting Tracy. Farthest alphabetically from Linda. So we got a couple of Tracy.
Okay, and the other thing that I would like you to do, once you think you have a name, why do you think it's that name? Okay, why do you think it's Anna or Tracy? Can you give me an explanation of why you think your answer is the correct answer? And I don't know what the correct answer is, so you're going to have to convince me. I'm going to go look at the participant list while you're thinking.
T is further away from L than A.
So this morning, one of the things we talked about was, where is the middle of the alphabet? So A is farthest from L. How far is A from L? And how far is T from L?
So Nicole said A is 11 letters away from L.
Uh-huh.
And I don't think anybody...
Hey, didn't Nicole win a prize last time? She's just so... It depends on which direction you're going. Yes, that's what we talked about last time too.
Yeah.
So Mickey says, and Mickey is one of our colleagues. She did the timeline video for us. So Anna starts with A, 11 characters away from L. Tracy starts with a T, 8 characters away from L. But going in a circular direction, Anna says T goes past Z and then through A to L. Oh boy. I'm getting,
So
wow,
Anna's got a loop going. She's looping. Yay.
Oh, it is Anna. Yeah, Danny's dizzy too. All right.
I love this.
So I'm going to do my finger counting. A, B, C, D, E, F, G, H, I, J, K, L. Okay, so that's 12. LMNOPQRST. Okay, that's 9. So I think it's Anna.
Yeah, I think so.
But- Anna, did you want a prize? I can drop it up on your desk. And which prize? Okay, that last time she said give it to someone else. So Tracy also works at BOSID. Tracy, do you want a prize, or would you like to give it to like someone who works at a school? Or I can give one to you and one to someone who works at a school too. Give it to a school person. Okay, so who's next on the list besides Tracy and Anna? Ooh, put your thinking caps on, everyone. If we take out Anna and Tracy, who's next? Who's next closest to Linda? Alphabetically. And if we have a tie, it's okay.
Farthest. Still looking at
Yeah.
farthest.
Farthest, yeah, you mentioned closest, but we're looking
Oh,
for
sorry. Please correct me. Farthest. I was just seeing if you were listening. Okay, thanks for joining us, Tracy. We'll see you next time. So whoever's left here, who is farthest from Linda besides Anna and Tracy?
And we've got another minute. We want to kind of honor your time. So
Carrie or
also-
Shane?
I'll also, as
Carrie
we're
or
thinking,
Shane?
I'm going to put up the feedback form. So
Oh,
as you're
yes, I
thinking-
forgot. Yes. So while we're trying to figure out if it's Carrie or Shane, please fill out our feedback form so we can make the next event even better. And our next event will be on October 26th, 2021. And the learning event flyer is here if you need it. And the link to the feedback survey is in the chat.
And we thank you for your attendance and participation. We love the rich conversations and the sharing of ideas. It's really a learning community here. So thanks so much, everybody.
Okay, wait, I'm putting here's the link to the survey in the chat. I think it's Carrie too. So Carrie, is she still here? Carrie Fitzsimmons.
Uh-huh.
Wait,
She is.
Carrie, aren't you from Wailua? I remember sending you something too. Simmons from Wailua. Yes? Give it to Shane. I think Shane has some of this too. Shane, do you want a prize? We were just talking with Shane this morning. I think he said he had some of the same items. No, thank you. He has an unopened box too. Okay. Well, Carrie, I can send you something else. What is the
They have
last
really
thing?
cool stuff, Carrie. They have really cool stuff. Carrie, look. They got these great. Yeah. You want it, Carrie.
She
Go.
loves the earbuds. I'm so glad you like the earbuds. All right. Well, we're at the end of our session, 3:30. So, Carrie, you're the winner, and then Celeste is next in line. Would you like me to mail both of you something?
Yes, let's mail them both.
Okay, sounds good. And if you want to stay around to chat with us, Phil, you're welcome to. I'm going to stop the recording now. I do remember to stop the recording. Okay, stop the recording.